Hey everyone, Mr. Skelton here. We are back at it. We're starting Unit 2, or we're in Unit 2. We're starting Lesson 3 today, and today we're going to be solving systems of inequalities. Inequalities, again, greater than or less than, greater than or equal to, less than or equal to. Those are your inequality symbols, and we're going to be solving them in a variety of ways, but mostly today just by graphing. And so we'll jump right in here with slide number 1. Your task is to be able to graph these linear inequalities together. If you look at the first one, it's already in y equals mx plus b form. That is the preferred way to do these. If you do look at the second equation here, it's in standard form, and you can graph something like this in standard form. I call it the cover-up method in Algebra 1. I can show you how to do this in class. For the sake of time, I'm just going to suggest to you, and what I'm going to do in the notes is put everything in y equals mx plus b form. But if you're interested to see how you do it in standard form, I can show you that in class. All right, a couple things to think about here. Let's just jump right into this first one here. Y is less than negative 2x plus 5. So we're going to graph that. Your y-intercept is at 5, and our slope is negative 2, so that really means negative 2 over 1. So down 2 into the right 1, down 2 into the right 1, up 2 into the left 1 there. And when I graph this line, you'll notice something different than maybe a normal line. You'll notice that it's dotted. Okay? Anytime we're graphing inequalities, if you have the less than or greater than symbol, that requires a dotted line. Likewise, if you have or equal to underneath it, that requires a solid line, just a normal line. Okay? Now, with inequalities, that means not equal to. And so usually when we have an equal sign there, the line represents possible solutions, especially if we're talking about two lines intersecting. A line basically represents all the solutions that work for that equation. Well, here it's not an equal sign, and so we have more than one potential answer. And so what we're going to be doing here is we're going to be shading. Okay? So you're going to have to shade properly, and there's a lot of different ways you can do this. You can pick a point either to the left or to the right of the dotted line, like 0, 0, and plug it in. So 0 less than, negative 2 times 0 is 0. Is 0 less than 5? That would be true. So that means that this point right here, 0, 0, falls into the solution set of this inequality. So we would shade everything to the or below the line. Now, I always use this method. I just look, if it's in y equals mx plus b, I just look at this y and then the symbol, and I say it out loud in my head. Y is less than, okay? And since we're talking about the y-axis, we're thinking up and down. That's the ways you want to shade. So I literally just take my pen or pencil, put it somewhere on the graph, and if it's y is less than, does less than mean down or up? Down. So we would just shade below, and I usually just draw lines, and I'll show you why here in a second. I usually just shade like this. Okay? So what this shade represents, the shade represents solutions. Okay? Your shade represents solutions. Now, in pencil here, I'm going to first solve this for y. I'm going to subtract 4x, and I want to put it in y equals mx plus b form, so I subtracted the 4x. This is still a negative 2. And then I'm going to divide by negative 2. Now, just a quick note here. Remember, when we divide by a negative number, what do we have to do to our sign? It's got to flip. That becomes 2x minus 6. Okay, so here's the second equation in our system. So at negative 6, I'm going to go down. Let's see, shaded too dark here. I can't find my numbers. 5, 6. So there's that point there. And then my slope is up 2. So 1, 2, and over 1. And is this a solid or dotted line? Since it's got an or equal to, this would be a solid line like this. And we have to shade this line. So again, I always think up and down. Since I have this here, I can just cover this part up. Y is less than. So less than means down. So anywhere on your graph, you want to shade down. Now, the nice part about this is you want to know or darken in your solution set. In other words, a solution that works for both equations. So basically what you want to look for is where my blue and pencil gray overlap, which would be in this region right here, and that's the part that gets darkened in. What that means is if I pick any point in this solution set and plug those points, x and y values, into both, it's going to result in a true statement. So this right here is our solution set. Okay? That's where all your solutions can come from, and that is how you graph a linear inequality. All right, let's flip it over. Something very similar, except now we're kind of changing the game a little bit. You'll notice we have absolute value. You know how to graph absolute value. We just did it in our last unit, so let's jump right into it. Since they're both in y equals, right, quote unquote equals, even though it's an inequality, we can just shift this. So this is going to shift to the right 3 and down 1. So to the right 3 and down 1, that's going to be your vertex. Remember, your vertex is your what we call h and k, right? Y equals a, x minus h plus k. That's standard form, so your h and k is your vertex, so that's our vertex there. And then our slope, you can make a t-chart for this if you would like. You really can. If you want to make a t-chart and plot points for this first one, you can, but if you remember, this is really, if there's your a value out in front of your x is going to be your slope, so this is going to be essentially up 2 and over 1. So I can go up 2, so let's see, it was down, so 1, 2, and over 1 that way, and then up 2 into the left 1 that way. And again, with an or equal to sign, or since this one does not have an or equal to sign, you're going to make this dotted, okay? So that's going to be dotted here, and that's going to be dotted there. And I do the same exact thing, so you're trying to figure out now where do I shade? Well, remember, you're going to shade either up or down based on what this says. So this says y is greater than. So anywhere on the graph, you're going to shade up. So we want to essentially shade inside of our v, okay? Let's take a look at our second inequality here. I'm going to shift this. Now, if you remember, if you have a number, like these are easy because it just says x minus 3. If you have something in front of the x inside of the absolute value bars, the way you find your vertex is you set whatever this is equal to 0 and find your x. So you would solve. So you'd get 2x equals 4, divide by 2, so x equals 2. So this is going to be 2 comma 3 because your k value is still 3. So at 2, 3, so 2 and 3, 1, 2, 3. There's my vertex there. And my slope is still 2, so I'm going up 2, over 1, and up 2, left 1 there, okay? And this is going to be a solid line. It's going to look something like this. Oops, it's a little off. And then this is less than, right? Y is less than, so I'm going to shade down. This is a little off here. Like that, and I'm going to shade underneath, okay? And again, what are we looking for? We're looking for where they overlap. So they're going to overlap everywhere in here, above this one, but below the one in pencil. Look something like that. And that would be our solution set. Okay? Everything that's shaded in. For our last question, it's a little bit of a word application here, word problem. It says, write a system for this situation, and then graph your solution. Let x be the number of golf balls, so that's important. So x is going to be the golf balls. Okay, so there's your x-axis, that's your golf balls. I like to stay organized here. And it says, let let x be the number of golf balls, and Dan has, and y be the number of golf clubs. So golf clubs. Okay, so there's your y-axis, and that's the golf clubs. Okay. We have to come up with a system. So we need two equations based on the information provided in this next paragraph. Dan is golfing and takes several things from his dad's golf bag. He takes somewhere between 6 and 8 golf balls. Okay, how do we write that as an inequality if x is representing golf balls? How do we write something that represents x golf balls between 6 and 10? It should look something like this, right? If x represents golf balls, then he's got less than 10, but he has to have more than 6. And again, it's not a line underneath it because it just says between 6 and 10. So that's your first equation. Let's come up with our second. But takes 5 or less golf clubs, so that's going to be written like this. Okay? And now we want to graph those. I'll do the x in pencil here. Now this may be tough. You're probably thinking, okay, how do I graph that? That's not like y equals mx plus b. You're right, it's not. But it's like what? X equals 6 and x equals 10. So think about what does x equals graph look like? Well, those are just vertical lines. So at 6, we're going to have a dotted line, vertical, that's x equals 6. And then we're also going to have a dotted line at 10. Now, where are we going to shade? Now, I know in the previous questions I said you would shade up and down. Well, in this situation, when you have a vertical line, obviously I can't shade up and down, but if it's between 6 and 10, let's use our brain a little bit here, just use some common sense, we're going to shade everything in between, right? Because you could have 7 golf balls, 8 golf balls, 9 golf balls, so that represents all those solutions there. In pen here, I will graph y is equal to 5. Remember, it's not equals, but less than 5. But what does y equals 5 look like? That is a horizontal line, solid, here at 5. Okay? And y is less than. Less than means lower. So we shade down. And what are we looking for? We're looking for where they overlap. So obviously you can see right in here, and you always want to darken in where they overlap if possible. And we're not going to go below the x-axis because we wouldn't have negative golf balls. And so anywhere in this shaded region, you could pick a point like, 8-2. Where's 8-2? 8-2 is right there. Does that work for this system? Well, if I picked 8-2, 8 is my x-coordinate. Is 8 between 6 and 10? Yes. 2 is 2 less than 5? Yes. Any point you pick in this shaded region would work. Okay? And I think that's all I have for you there. So again, I know we didn't do a ton of examples there. So if you have some follow-up questions in class, I'd be happy to answer those for you. But we're solving systems. Make sure you shade properly. Make sure you use the right line, dotted or solid. And make sure you put things in y equals mx plus b. That'll make life a lot easier for you. Okay? All right, we'll see you later.